Hi, welcome to the EEVblog, an electronics engineering video blog of interest to anyone involved in electronics design. I'm your host, Dave Jones.
And it's because
yes, true, but it's not sort of to the ideal of how to build a Reprap. It's not self-replicated.
That part there, on these printers, is about a 2-hour print. So yes, they actually prefer them printed because when they mould them, they tend to be brittle and not as well made with all the internal holes and things that are in them.
See, these are all the prints that he did on this.
Yes.
That's where these come from, except for this one, which is
that's yours.
This creamy coloured one is ABS. All these others are PLA.
So that's quite durable then.
Oh yeah,
ABS is what they make cars out of, bumpers and dashboards and things like that.
Because the original stuff was weak as anything.
This is just a bit more brittle. Yep. This is my rep strap here that I've made up to print off the parts for my Reprap printers.
Right.
We've made 3 of them so far, or making 3 of them so far. One for the club and one for a couple of myself and other guys.
Yep.
This one's actually just about finished.
Right.
All right.
So this machine here actually is just designed for duplicate manufacturing parts.
We'll print everything that one of these will print.
Right.
It just when I started it, I couldn't get access to the printed parts.
Right. Okay.
So I thought, well, what am I going to do?
Right.
So we went and made a wood one.
So you made just a jury-rigged Reprap.
Absolutely, yes.
Right.
Yes.
Okay. And is that basically using the same instructions as what's on the site?
Yes, yeah, pretty much. This is actually on the site as a wolf strap.
Oh, okay.
The basic design is there. It's got my own variations on it, but it's there as a design. Yes.
Fantastic. And you've produced which parts on here?
All of the white parts here.
This will be more
and the red part there.
Yep.
By 3 different printers so far.
Right. Oh, okay. Yep.
2.5D.
Excellent.
So this one was printed on a slightly
You
different
do
printer
one,
because it's
and then
actually
the
made from
next,
ABS.
the next, which is not unlike that.
Which is different from plastic. This printer's actually Rob's here. He's just about got it working.
And I've got my metal cutting machine here today.
And you've got what have you got?
This used to be a key cutting machine.
Oh, okay.
And
you
we've
modeled
just
it.
attached steppers to it.
Yep.
And sort of when I get clear of this one working, which is tantalisingly close, I'll put a bit more effort into this,
Excellent.
making bits for model steam trains.
Oh, fantastic. Model railway. What gauge?
So I'm all sorts of nuts.
Gauge?
5-inch, 3.5, 7.25.
Yep.
We're going to have the Australian convention in 2013, 2014 up at Bulla,
Right. Nice.
up near the airport.
Excellent. Love model trains. And I love the Reprap. It's very cool. Very. So, how long did it take you to build?
It's probably about 3 or 4 weeks worth of build time, but over probably 4 months.
Yep.
Yeah.
Right. Okay. And it worked. And how's the resolution on it? Is it good?
It should be identical to the Reprap.
Right. Okay.
Basically, all the electronics, all the motors are identical.
Right. And the extrusion head's the same?
The extruded head is the same. So it's just the fact that it's on a different frame, which has actually allowed me to get up and going fairly quickly.
Yep.
Because all the settings are pretty much the same.
Right. Nice. And is that what diameter is that? That's like
That's
a
3 millimetre.
3 millimetre.
Goes down to a 0.5 millimetre extrusion
Right.
at the moment.
Yep.
Yeah.
Excellent.
So that was my very first print, the spool.
Oh, okay. Yeah, you actually manufactured the spool itself. Okay. Nice. And that's well done. So the platform moves.
Yes. So the platform moves
Yep.
that way. This.
Yep.
And that'll go up and down with the threaded rod.
Nice.
And
And how long does it take to print parts for?
Well, that part there was about 40 minutes.
40 minutes?
And this part here, which is a bit larger, that's about a 2-hour.
I haven't got that far yet.
2-hour part. But one of the things you can do to tweak them is speed them up quite a lot.
Right.
Yeah.
Nice.
Yes.
2 amps.
All right. Well done. We're here with Paul, and Paul's got a.
Hi. An open PCR machine.
Yeah, and this is a piece. It's a DNA analyzer.
DNA copy machine.
DNA copy machine. Unfortunately, the light's not that great here, but there we
go.
go. We have a light.
Nicely done, Andy.
Let there be light. There we go. Tell us about this.
So this was started as a Kickstarter project, so funded over the internet by people that were interested in creating or being part of the creation of it.
Yep.
And a couple of guys, Tito and Josh in San Francisco, came up with the design, and it's actually a really lovely design. So originally when they started it, we thought it was going to be a project we'd have to solder a lot, but they've actually gotten to a point where it's now pretty much a kit set. So Pinocchio case, PC power supply, PC cooling system, one board that they've created themselves. There's actually an Arduino Uno sitting underneath.
Okay, yep.
And what it does is basically gets a program loaded to it that has timing around heating and cooling cycles. Take a sample of DNA, put it into one of the little mini test tubes here.
Okay.
Pop that in with a couple of enzymes in there, close it up and leave it running. Might take an hour or so to run through, and basically takes that DNA sample and magnifies it multiple times, and then you can go and do further analysis on that. So you do things like, maybe you're suspicious that your local fish shop is selling the fish that they claim they are. So let's take a sample of that fish and go and analyse and see whether it really is that. We might be worried about a product we're eating that might be genetically modified, so we could find out using this machine.
But you would have to have some sort of reference like a golden reference to compare it to, do you?
You do, that's right. And even so, this was $512 US. They're now about $5.99. So reasonably good price, and you can definitely have one in your own home or in your own hacker space. The problem is that the reagents that are used to run the cycles are specific to the type of thing you're analysing, and they need to be kept perfectly frozen. So you can't use a domestic freezer that does the cooling, anti-freeze sort of cycle. So after signing up for this, I then decided that having one at the hackerspace wasn't that practical. So I've actually donated it to CSIRO.
Nice.
So it's going into the secondary education program, so kids will be able to use it.
Fantastic.
To learn about it. So
brilliant. So it basically just heats it. Does it
Heating
do
and
any?
cooling.
Right, it's just heating and cooling. That's all it does. Right.
But needs to control it very precisely. So
Peltier.
yeah.
Oh, okay. Yep. So it's a large. Yep.
Where's the Peltier? Oh, on the side there.
Yeah.
And they're heat pipes, are they?
Yes.
Excellent.
So it's basically just a standard PC cooling type system that's been added to and extended with a couple of custom aluminium blocks and so on. The bit that took the longest to get right was how to get this lid assembly working. Originally there was thoughts about making this a mechanical, electromechanical assembly, but now it's just a simple screw down mechanism that works pretty well.
So how long does it take to heat up and cool down the samples?
Well, depending on what you're sampling, you use different programs for that. But doing a run as we were, the very first run we did took about an hour to run. Can take longer than that. That's probably about the shortest, I guess, that you could run.
Right. Is that an LCD on the top?
Yes, it is.
Right. And what is that? Just info?
Yeah, it basically just shows you where, how many cycles has it done, is it heating, is it cooling, what's the temperature at the moment, and So
Very cool. So you can almost buy this as a kit?
You can buy it as a kit.
Oh, you can actually buy it as a kit.
You can actually buy it as a kit.
Right.
So this was one of the first alphas. So the starting crowd all got their names.
There we go.
on the side of the board.
The names, they're famous. There we go. Special thanks to the first DNA hackers.
Yep, that's
Beautiful.
right. So
and there are other contributors to the project?
Yeah, so this is pretty much the core team that made it all possible.
Yep. Excellent.
And of course Tito and Josh, the guys that came up with the design.
There you go. Fantastic. And that's fairly new, is it? 2011?
Yeah.
Right.
Hot off the press.
Right.
So we built this about a month or two ago.
Right.
And I've got another one that I still need to build up. So we've got two of the first ones in Australia, which is nice.
Awesome.
Yeah.
How many of these have been built so far? Do you know?
I can't remember what the first lot was, maybe about 200, but I think the orders are in way past that now. So.
Wow. Who would have thought there was a demand for a DNA sequencer?
Well, some of the things that school kids are doing with these things are amazing. So, I mean, this is one piece in the chain of working with DNA, but there's a competition that's run each year, and I can't remember the name of it, but basically school children are asked to come up with a modified organism that could do something useful in the world. So, for example, they might do things like take a bacteria, genetically modify it so that when it's in solution and there's lead present, it will glow.
Right.
So that you could understand whether the water's contaminated by dropping this bacteria in, it glows if there's lead in the solution.
And school kids are doing this sort of stuff these days.
Yeah, correct.
Totally changed since when I went to school, let me tell you.
Yep. The fun one that a lot of people do is glow in the dark yogurt.
Right, yeah. I can imagine that's
pretty easy and common one to do. So yeah.
Good fun. Thank you very much, Paul.
That's all right.
That's awesome.
That's.
Gavin, meet Colin Mitchell. There we go.
I think I read every single one of your books when I was in high school.
Well, that's right. That's the very thing that you want. It's something simple that doesn't turn you off.
Yes.
And that's exactly that's right. It's exactly what I was saying
Can
to
you
you
hold
the
that for
day
a
before.
It was a great format.
He wants to come in between us.
No, we have to do it. We are not worthy.
No, that'd be silly. No.
We're not worthy.
We are not worthy.
No.
We're not worthy.
That's the whole.
And you can smell it. I love the smell of it. But I assume it's ABS? Oh, PLA. Okay. Right. Oh, ABS is, it'd be toxic, wouldn't it? Right. Nice. Awesome. I'm here with Andy from the Hacker Space, Melbourne Hacker Space. Thanks for joining us, Andy.
Oh, thanks for coming along, Dave.
No worries, mate.
It's been a big night tonight.
Yeah, it's huge. Big turnout out here. It's massive. We had to come out of here to get some decent audio. It's crazy.
Yeah, it was about half a dozen projects going on in the garage, laser cutters, 3D printers, and everyone's just going, talking about them all.
Oh, it's crazy. When did you start it?
Well, we started in early 2009. A couple of us, John Oxer and others, we've been talking about what would be great to have a shared workspace.
Right.
And at the same time, there's a Wired magazine article talking about the hackerspace movement around the world that is emerging. And it seemed that at the same time, the Brisbane hackerspace, Sydney, all sort of just popped up like mushrooms roughly at the same time.
Oh, right. Okay. And it's always been here in your garage?
So far, we've well and truly outgrown it.
How many members? How many?
Well, it's hard to give a specific number. There's over 300 on our email list.
Right.
There's about 30 to 40 people who rock up throughout the year, and on any given night we can have 20 or more people in the garage as we have tonight.
Yeah. Any issues with setting up a hackerspace? If somebody wants to set one up, what are the pitfalls? What are your insurance? Do you have to worry about? Anything, noise, neighbours?
I think all of those things. I think the thing about hackerspaces, they have a lot of similarities. So you can go to hackerspaces.org and they have design patterns or recipes for hackerspaces, some hints about what to do and what to avoid.
Okay.
But each hackerspace also has its own culture, I think, depending upon the
I'm sure
the
it
core
would.
members,
The
projects they like to work on, and the actual physical space they have.
Right.
So I think the main thing is to build up a core of people who can help newcomers, who can lead projects and who can welcome beginners. Because I think the hackerspace culture, and particularly things like around the Arduino community or the 3D printing community, is as much about sharing knowledge and trying new things and bringing people into the fold. Yeah.
So do you have? Is it mainly old timers here, or do you get a bunch of beginners turning up? What's the ratio of beginners to?
Quite a range. We've had from parents, our fathers with their 13-year-old sons.
They turn up. Kids. Fathers turn up with their kids. That's great. I love that.
That's great. And we do have a lot of grey beards, grey heads, people who are retired or who've been in the industry for decades, and they're often keen to pass their experience on. And so it's like this closing of the loop from people who have loved electronics and hacking all their life to passing on to the next generation.
Fantastic. So there's a core group that turn up pretty much every week, and then there's stragglers, just your regular drop-ins, just turn up occasionally. And
as a group, we're focused very much on trying to have good group projects. So we start off with a CNC mill, which we've been developed over a couple of years by a number of people leading that project. We've had a number of Arduino projects. Each year we're part of the LCA Arduino MiniConf in terms of deciding what the project is, helping John Oxer put that together.
Okay.
And we've competed in the Great Global Hacker Space Challenge.
Yep, saw that.
And so early on we did a lot of Arduino work, and then more recently there's been a lot of interest in 3D printing.
Right.
And so
yeah, that's been a big boom too. And there's almost hackerspaces starting up just around 3D printing
projects, like things around quadcopters,
oh, right,
mills, rocketry, avionics, vehicle telemetry, a few different type of robotics projects.
Yep.
And so a hackerspace can form around those sort of group projects,
right?
And then people come along with their individual projects to either share what they're doing,
yep,
or to
get help or something like that, or
And so we had a young fellow who's just joined recently. He had an idea around controlling shower hot water temperature with presets.
Yep.
And so he's come along, and he's the 3D printing guys have designed and printed gears for him to drive the solenoids.
Nice, yeah.
And he's got some I guess some help with the electronics, and he's done his own board. And so that's another great example.
Yeah. Excellent. So, what's the future? You're going to move? You're looking?
Oh yeah.
You're trying to get a new space because this is crazy. You can't continue in the garages. Yeah.
Well, I'll tell you, a number of people ask, how's my family cope with this happening every week?
Exactly. How do they?
And well, my family's been very forgiving, I guess very tolerant. But also, if somebody said to you, like, every week people are going to come around to your garage and they're going to work on laser cutters, and you're going to fly rockets and helicopters and build robots and stuff like that, and print things, you go, that's just, and DNA replicating machines. You go, that'd be awesome if people did that. And that's what happens. And I've got a young daughter, and she comes along, and she's more of an artistic bent, and she can see people doing 3D modelling and using Kinects for scanning. And so I think it's a wonderful environment for kids to see what's possible.
Absolutely.
Yeah, you don't need permission from the government or some industry body to go and create something. Just do it yourself.
So you're looking in Melbourne, Seabit, like actually nearer to Melbourne? We'd
like to be along a train line. A lot of our members use public transport.
Right.
So it's that trade-off in Melbourne, Sydney, expensive cities to be
very
close.
Yep.
And yet, and also we don't want to disenfranchise any members because of fees are too high.
Yep.
So we've spoken with councils, government, other not-for-profit groups. There's a group called the ATA who have an electric vehicle group. And
I know the ATA. Yeah.
So we'd like to potentially share a space with them because they work on electric vehicles.
Right.
And that's the other thing. We typically like to work on projects that have some community good.
Yep.
So things that are useful for education, like our open lab project,
right?
An Arduino-based science project for high schools.
Yep.
We're talking towards the end of the year at the I think it's called IT Assist, which is technology for assisting disabled people.
Okay. Excellent.
Or things like looking at how to save energy. So I think doing community-minded projects and having members where you're not charging a fortune for facilities fee means that we need to also find assistance here through government grants.
I was going to say, what about sponsors?
Yep.
Are you actively trying to find sponsors, or is it?
Well, we probably should more than we are. What we're doing at the moment is we want to make sure we've got I think if you just look like a bunch of guys and women in a garage, it's perhaps difficult for government to take you as seriously as if you've got a decent location. So we've
well, it's a chicken and egg kind of thing, isn't it? So, geez.
So, but many it depends where we are. Different hacker spaces have some have been fortunate in terms of getting great peppercorn rent locations.
Yep.
Others, members have just banded together and just really stretched themselves
financially and
taken a bit of risk.
Yeah.
But the main thing for us is that it needs to be fun, people coming on and learning, and we're not taking on the stress of commercial rent or other things that cause us to lose focus on what we're here to do, which is to enjoy ourselves.
Right. But are there any, like, is it a formal organisation? Is it a formal legal organisation? Oh, it is?
Yep. So we have an elected committee.
Okay.
We're a not-for-profit organisation. We have bank accounts.
Okay.
So when it comes to we'll be able to take out a lease. Insurance. So we looked at there's the Men's Shed Association in Australia, and they've been around for decades, and they've got their insurance sorted out. So we asked them, they showed us what insurance policies.
Right.
So when you've got saws and drills and other things,
accidents.
We take safety very seriously, but at some stage, someone may accidentally
exactly.
pick up the wrong end of a soldering iron or something like that. And so you need to have all those things in place.
Unfortunately, you've got to have the insurance just to cover yourself. When you've got Joe Public coming along pretty much. But this isn't an open hackerspace, really, is it? You can't just wander in off the street because it's not the address isn't published. Is it?
You can wander in off the street if you found us.
if you found us, but you've got to find the address. It's not openly published, obviously.
Well, it's simply because we wouldn't be doing any of our members or ourselves any favours if we said just
turn
up.
In. Yeah.
So so if people find us, we would welcome them and say please join us and help us look for location. But we're not making it. We're not sort of advertising saying come one, come all.
Right.
So good.
Excellent. So it's looking good.
Yeah. Well, thanks for that. Well, thanks for coming
excellent.
Down.
Thank you very much. All right, we have Luke, and we've got a laser cutter.
This is our laser cutter. It's a CNC laser cutter with a 50-watt carbon dioxide laser, and it cuts stuff and sets stuff on fire.
Awesome. And it's quite big. It's quite sizable.
Yeah, it's quite a roomy one.
All right. And how did you score this?
The pancake sheets are fantastic.
I'm not the best person to answer that, actually.
It just magically appeared.
Yeah, it was
donated.
It was acquired at minimal cost from some people who were getting rid of it.
Excellent.
Here's a little. I don't know if you can focus on that, but it's a little piece of acrylic that's been cut up.
Anyway, that's pretty cool. I like it. And what's the maximum size it can do?
Probably like, several hundred millimeters by several hundred millimeters. Yeah. So
can we have a look inside?
Yeah, we certainly can.
There we go. So that is a 50-watt laser.
No, the 50-watt laser's in the back.
Oh, right. Oh, it's in the back, and how does it?
It has a bunch of mirrors where it sends the beam around.
Oh, wow.
It's a water-cooled laser tube.
Yep.
Mirrors.
Oh, there's the mirrors. Yep.
One of the mirror holders there, and there's a mirror inside that. Another one there.
Yep.
Another one there.
Oh, okay. Right.
So the arms move it around.
Right. And
then the mirrors just turn the beam at right angles.
Got it.
And refocus it down through
down into there. So there's another mirror inside the head.
There's a mirror there, and there's a lens at the bottom there.
Everywhere you see 3 of those adjustments, you know there's a mirror there.
Right, okay, got it. Awesome, what an awesome bit of kit for a hacker space.
That's the some of the acrylic we have planned to cut up.
Right.
Eventually.
I think it is going to droop everywhere, unfortunately.
What are we printing? It's a Mickey.
How did you do that so fast? I had to ask.
Oh, there we go. Oh, already got made. Oh, there we go. That's the one made before.
Meanwhile, here's one we made
Previously, yep. Yep. Awesome.
So now it's going to go as a head.
I don't care what the nozzle size is. Right. I know what's going out. Right.
That's your resolution, and you can get it down to centimetres. Or better than centimetres, actually.
This software
That's a different principle. That's a Doppler effect. This is an app with a Reprap Printers. So you're getting the Doppler shift, the difference in frequency, whereas this is an actual kind of flight thing.
All right, we've got a secret project here, do we?
Well, not too secret, but basically to use an Arduino telemetry board that has GPS and barometer, has Zigbee for radio comms, and
right.
So that basically hooks up to this box, which is the telemetry on the motorbike.
Right. Aha. There we go.
So you can just do things like you can eventually show you throttle position.
Yep.
Once we lock the bike up, and should get RPM. It's cable, I think. Oh, it's going to close the throttle, sorry.
And this is his little project, is it?
Oh, this is Mark's baby.
Right.
What's going on here?
So does he sell this commercially?
Yeah, it's a commercial. This is a commercial product, not been using the hack.
Oh, right.
Throttle. So
we've got a GPS on the back, by the looks of it.
Yeah, GPS unit. There's a micro SD for storage.
Yep.
There's a barometer. There's a 3-axis accelerometer, temperature. There's a Zigbee radio.
Yep.
And also with a serial connection, talk back to a mobile phone, which then gives me net access.
So you can do that in real time.
Yep. Exactly.
Excellent. And you incorporate sensors into your body suit as well.
Yeah, we'll be gradually working wearable stuff. So, so the idea would be to have bend sensors, gyroscope, accelerometer on your jacket. So you also
on you actually riding. So as you're going around the circuit, you can actually see the.
Yeah, well, you probably want to do it while you're riding. You probably want to concentrate on what you're doing, but exactly. certainly other people can look at the real time.
Other people in the pits can
look at the real time analysis.
Actually, look at the real time data,
and you can look yourself later, so you can see what gear you're in, how fast you're going, what your RPMs were, and also how you're positioned on the bike.
Yep.
This is of course stuff that professionals have had for many years. Yeah. But what's interesting is as a hobbyist to have access to information just to see what you're doing in terms of braking and controlling the bike.
Fantastic. Yeah. And you can hack all that using an Arduino.
Yep.
Pretty much.
Certainly can. Yeah, it's just a great workhorse.
Sorry, 0.4mm hole, which is 0.15748 inches from design, prototyping.
Laser is no good.
Now the step drive.
Yeah, we've got John from Freetronics here. John Oxer. And he's got some stuff for me apparently.
This is an old one.
What do we got?
Mark just pulled this one out of the archive. This is a 2010. Which is the first Arduino compatible board that we worked on.
Right.
So the name 2010 is from the year it was made because it was based on the De Milanova design, which is 2009 in Italian. So it's very much like a De Milanova, but it's got all of the parts pushed down to make some prototyping area.
You've got a prototyping area on the bottom.
We fixed the stupid USB connector. Made it a Mini instead of a
Mini
huge
B.
thing.
Yep.
Moved the LEDs out onto the edge so you could see them when there's a shield on top.
Yep. Pretty basic.
Some general
common
polish,
sense
basically.
stuff like that. And there we go. Ta-da! Freetronics board. Check them out. Freetronics.com.
Yep, that's it.
Yep, that's the one.
Yeah, the cool thing about this is the prototyping area on there means that you can use this as a starting point for a project, but then add your own parts. So you can do like a little single board custom solution really easily.
Excellent. I like it. So that's an old one. That's ancient.
Yeah,
right?
that's an old one.
Is it still available?
No. It's been superseded by the 11. What else do we have in here? That one is an 11.
That's the latest brand spec and new one.
Yep.
Right.
So
what are the differences?
The difference is that instead of having the FTDI chip for the USB to serial converter, it has an 8U2, which is an AVR.
Which allows you to do like a USB host.
Exactly.
Kind of. Yep. Yeah. Right.
So it also allows much faster uploads and things like that. So this is like the tweaked, updated version of the design, but functionally it's pretty much the same. Right. So this works like an Uno. It's So when you're programming in the Arduino IDE, you just select Uno as the target board, and that works perfectly.
Yep. And I love it. Designed in Australia, people. You beauty. All right.
Now this one is one that Mark has been working on just recently. It's called the USB Droid.
Right.
Very similar. It's compatible with Arduino, but it has onboard USB host.
Got it.
So you can use this for connecting to an Android tablet or something like that.
Yep. And it's got a micro SD card, I see.
Yeah. So the idea is that with this, it's compatible with the Android Open Accessory Development Kit.
Yep.
So you can use it for making Android accessories.
Fantastic. There you go. If you're playing around with Androids, check it out. Freetronics USB Droid. Beautiful. All right.
Just in that
what
box
else?
It's more of the same. Let's see what else Mark has packed. I'll get back to those things in a minute.
It's endless.
These are interesting. This is one of the first things we did actually. It's a network shield. So it's an Ethernet shield. The difference with this, unlike a lot of the Ethernet shields that came before, is that we pushed all the parts up to the end. Once again, the idea is that you shouldn't have to add a prototyping shield on top.
Right.
And we added power over Ethernet support. And the way this is set up, it has a little header on here, so that if you want to do really cheapy DIY power over Ethernet, all you do is cut into the cables, send like 9 volts or something down the spare wires. You put these headers in place, and the Arduino just powers up straight off the LAN cable.
Yep. So you can power stuff, you know, 100 meters away.
Yeah,
down
exactly.
Down the Ethernet cable.
Yeah,
there you go.
But the thing is that there are really 2 ways of doing power over Ethernet. One is the really cheapy DIY approach. And the other is official power over Ethernet.
Yes, which I've worked on those.
Yep.
48 volts.
48 volts
48
with the
volts.
signalling mechanism and everything.
Yep.
So the idea is that is a module that you can solder. You take the jumpers off
Yep.
and you solder that in place.
Right.
And it gives you full 802.3 AF support.
Nice.
So you can run that
there you
off
go.
a commercial
There's
PoE
a
injector
Freetronics power over
Ethernet.
Ethernet.
Adapter.
Ta-da!
So that means
Just trying to focus on my head, folks. Sorry. There you go. Anyway, it's very cool.
Yeah,
Check
so
it
that,
out.
So that gives you the flexibility
Yep.
of doing the really cheap approach or compatibility with full commercial systems.
I love that you can just plug it on there, but then that, right, does it go upside down? No,
No, it goes
up,
that way.
All the way down.
Yeah, and there are little standoffs that give it mechanical support up towards
Right.
this end as well.
Got it.
So you just put
And
it
you can
down,
still-
solder it on, and then
Yep.
clip off.
And you can still plug a shield on top?
Yeah,
when
you
it's
can
on?
still stack another thing on
Yep.
top. It takes up a little bit of space, but
Yep.
yeah.
There we go.
That's good.
It plugs onto the Ethernet board. Yeah.
Now,
Forget
this
the
one-
names. You got too many. This is
Yeah,
ridiculous.
there's lots.
All right.
Yeah, okay, you can grab one out of the box.
I'll pull them out of the box.
Okay. So you can find an Ether 10, that'd be cool. This is a receiver. So it's basically a very simple 433 megahertz receiver module.
Yep.
So I can just do OOK or that sort of thing, type encoding. And it's useful for picking up signals from domestic appliances like weather stations often transmit on 433 megahertz, car alarms, garage remote door controllers, home automation
Yeah,
systems.
there's a whole bunch of stuff. Yeah.
Lots of stuff.
Okay.
So originally I did this for intercepting signals from a weather station.
Right.
And Mark did all the work decoding the protocol and
Got
that sorted out. So we can record data off a really cheap weather station and data log it.
As well
which
as
is cool.
lots of other
I've also used these with
not
rocket
entirely
telemetry.
legal things you could use it for, I'm sure.
Yep.
Brilliant.
So yeah,
Beautiful.
I've used this to receive data from a rocket telemetry system as well. So little Class C rocket with a tiny transmitter in it.
Yep.
And pull down some data. What have you got there?
No.
No?
Must be in one of the other boxes.
Maybe in this box? What have we got? Yes, that's the Ether 10.
That's
So
the
that-
Ether 10. Is that your latest?
Not quite the latest.
Not quite latest. That's the Freetronics Ether 10.
So
nice
that-
board. Check it out.
Yep, so it's an Arduino with built-in Ethernet.
Yep.
With power over Ethernet support once again. So the idea is it's a single board, you plug it onto the end of a LAN cable, powers up and away you go.
Awesome.
So it's great for home automation projects and things like that.
Yeah.
I've
Because
got
the
a bunch
hard
of
part
these.
is getting power to stuff.
Yeah, that's right.
It's I know, power over Ethernet's great. I love it.
Yeah, so I've got a bunch of these things buried in the walls of my house, none on the floor and in the ceiling
Right.
and all sorts of things. In fact, light switches in my house have
Yep.
one of these behind them mounted in the wall.
Oh,
so what
okay.
happens is that
Yep.
the light switch just has a control surface on it,
Yep.
which sends a signal to the Ether 10, which then connects to a web service. So I've got a Linux box running in the house.
Linux box drawing 100 watts to
It's,
turn your lights on.
no.
That's not exactly
it's
eco-friendly.
a solid state little.
solid state.
Yeah, it's
right.
like a router running embedded.
Right,
like
so it's
running
only
a
running 10.
Yeah, it's only a few watts.
It's only
Yeah, it's
110 watts.
it's basically the same thing as like a network router.
Okay,
But
right.
I've got a Linux
okay,
distro running on it.
You're off the hook.
Thanks. Yeah, so that's the same thing, but out of the box.
Out of the box. There we go. There's the Ether 10. Ta-da! It's not the best light in here, sorry, but there you go. Go check it out, freetronics.com.
Another one we've just done. This is a prototyping shield with terminals, screw terminals down the edge.
Yep.
So this is called the terminal shield. The idea is that makes it really easy to connect external cables to your project.
Yep, piece of cake.
Yeah,
I like it.
We also have prototyping shields without that.
Yeah, I've
that-
seen the wing shield ones
Yeah, the wing
as
shield,
well.
yeah.
The wing shield
Yeah, there are a
does
few
the same
different versions
thing.
of that.
Yep.
And I think that might be most of what we have here. Oh, there's a kit version of an Arduino called a Kitten.
A kit, oh,
That's
right.
a kit version of the 10.
Kit 10, there you go. Build it yourself, if you can.
They're really simple. Actually, we earlier this year we had a bunch of these at the Arduino MiniConf in Brisbane.
Yep.
And got about 50 or 60 people assembling these, and most of them were software hackers who'd never done any hardware at all.
Right.
So we actually taught them how to solder, and they assembled these in the space of about an hour and a half and powered them up and got them all running.
They all worked, I was going to say.
They all worked. It was fantastic.
Beautiful.
And that is an LCD shield, so it's a 16 by 2 character LCD with some input buttons for navigation or menu or whatever.
Right, okay. Yep. Excellent.
And Mark very cleverly mounted the LCD from behind the PCB.
Yep.
Bit of lateral thinking, so
Yes.
that it comes up.
I've done that
slick.
before, it works quite well. So there you go. It's a, if you're looking for a novel way to mount your LCD on your board, you can actually do a cutout in it and mount the module on the back and have it protrude through the front like that. And they've got extended, looks like nice brass, are they brass?
Yeah. Brass actuators, tactile
brass
buttons.
Actuator, tactile buttons, very nice. So, excellent.
Well,
it's the LCD shield.
It's not too exciting, but this is a prototyping shield, so that's just basic area for development. This one is a kit, which is an RFID lock shield. So it interfaces with an RFID reader module. It's got a relay for driving an output, like a solenoid door lock.
Yep.
So these things are pretty cool. I actually have an RFID chip implanted in my arm, and I can use.
Seriously?
Yeah, seriously. And,
where is it? Show us.
It's just in here.
Hang on, folks. Hang on. Jonathan Oxer has, and he is fully chipped. He is living the.
It's just in here.
You've got
you can't see anything because it's been there.
Can't see.
It's been there about 4 years now, so the scar's all long gone, and
Come on, you got to be having me on.
No.
You've seriously got an RFID chip in your arm.
Yeah. There's plenty of footage online of it being used. I was on some.
All right, there you go.
Stuff,
He's been chipped. The government are tracking him. He's beautiful.
So, I just use an animal implanter. But with this, basically it means I can walk up to my door, wave my arm near it, and the door unlocks. So
insane. That's dedication. All right. No, give me a passcode any day.
A good old retinal scan.
Yeah, right. Retinal scan. Yeah, that'll do it. I don't want the government tracking me.
No.
No, I'd have to put my tinfoil hat on. Excellent. Thanks, John. And that's Freetronics. See ya.
Thanks, Dave.